friends, thank you for joining me still on GCE 2024. This is November December objective test 1. With us here is question 21, 22, and 23 respectively. In my previous video, I've solved question 1 to 20. Let's look at how we can handle this further mathematics GCE 2024, November December. Question 21 read, if the root of 3x squared plus 7x plus p equals 0 are alpha and beta, where p is a constant, we are asked to find the value of alpha squared plus beta squared. Alpha squared plus beta squared in terms of p. In terms of p means our final answer there will be p. Let's look at how we can solve it. First thing for us to do is to write down the solution, and after that we have to identify this question 21 is from which topic. This is from roots of quadratic equation. That's further mathematics for SS1, roots of quadratic equation. We have to recall the symmetry properties or the identities under this root of quadratic equation as far as this question is concerned. Solution to 21 now. Recall that alpha squared plus beta squared will be equals to alpha plus beta all squared minus 2 alpha times beta. Very important, and this is the identity we are to use. Again, we have to recall that alpha plus beta under the root of quadratic equation is minus b divided by a, comma alpha times beta is equals to c divided by a. These are very important properties as far as root of quadratic equation is concerned, or as far as this question is concerned. So the first thing for us to do is to pick the equation that was given to us from the question, which is 3x squared plus 7x plus p, and compare it with the general equation of general quadratic form, which is ax squared plus bx plus c equals to 0, given that a cannot be equals to 0. So our a here is 3 by comparing, b is 7, the constant c is p. Very important. Then the next thing to do is to find alpha plus beta, then alpha times beta. That's the next thing to do. Very important. Okay. Let's find alpha plus beta now. Alpha plus beta now will be equals to minus b. Our b is 7. That will be minus 7 divided by a, which is 3, comma alpha times beta. Alpha times beta is c over a. C is p divided by 3. Very important. Okay. So the next thing for us to do is to use this identity and substitute into this general formula here, or general identity here. Very important. We are asked to find the value of this. So let me remove the question in terms of p. Let me remove the question up to this point. Our next thing to do is to substitute. Alpha plus beta here is minus 7 divided by 3. That will be minus 7 divided by 3 all square. That's this square now, minus 2 into alpha times beta. Alpha times beta is p over 3. P divided by 3. Very important. Then we simplify. Minus 7 square is 49. Then minus 3 square, of course, is 9. Minus 2 times p, that will be 2p divided by 3. Okay, the next thing to do is to find the LCM. Is to find the LCM of 9 and 3, which is 9. 9 into 9 is 1 times 49, that will be 49. Minus 3 into 9 is 3 times 2, that will be minus 6p. Very important. Okay. This will be the simplification. Then we check which option is correct here. Option A is 49 minus 6p divided by 9. Yes, that's the correct answer. The correct answer is option A, which is 49 minus 6p divided by 9. Very important. So the correct option to question 21 is option A. Very important. Okay, let's quickly move to question 22. Let me click here to see how we can achieve that. Okay, question 22 now. Question 22. Uh, let's see how we can achieve that. Question 22. Read, given that vector P is 3 column 2 column 3 and vector Q is minus 5 column 1, we are asked to find vector R such that 2P plus 5R is equals to Q. This is from vectors under vectors. This is from vectors, yes. Very important. That's applied mechanics. This is under vectors. Uh, these two is here are scalar. 2P, the 2 here is a scalar, P is a vector, 5R, R is a vector, then this 5 here is a scalar. Very important. Let's look at how we can simplify this. To do this, we have to make R the subject of the formula because we are asked to find vector R. So, let's write down the solution. That's solution to 22 now. We have 2 multiplied by vector P plus 5 multiplied by vector R is equals to vector Q. So let's make R the subject of the formula. This will be 5R will be equals to Q minus 2P because this is plus 2P. When you cross this equal sign, it will be negative. Next, we divide both sides by 5. Divide both sides by the scalar 5. R now, which is vector R now, will be Q minus 2P divided by 5. The next thing is to substitute. We are told that vector Q is given as minus 5 column 1. Let's substitute. R now will be equals to minus 5 column 1. That's Q now minus 2 into P is 2 column 3. Very important. Let's take it here. R now will be equals to minus 5 column 1. Then minus, let's distribute these 2 over this. 2 times 2, that will be 4. Minus 2 times 3, that will be 6. So, we'll have, let me leave this minus. We have 2 times 2, that's 4. Then 2 times that is 6. Let me leave it this way so that we can use this minus to distribute. Finally, then divided by 5, there's 5 here, divided by 5. Let's subtract minus 5 minus 4, that will be minus 9. 1 minus 6, that will be minus 5. That's minus 9 column 5 divided by 5. Very important. Finally, minus 9 divided by 5, we have minus 9 over 5 column minus 5 divided by 5, that will be minus 1. So the value of R is minus 9 divided by 5 column minus 1. Let's check the correct option. The correct option is option D. The correct option is option D, minus 9 divided by 5 column minus 1. This is column vectors. We can represent vectors in 4 different ways. The column form, the row form, coordinate form, and the polar form of representation of vectors. Very important. Let's move to the last question. That's question 23. Question 23 for this presentation. Okay? Solution to 23 now. Let's write down the solution to 23. The question reads, a body moves so that the distance s meter covered in time t seconds is given by, the distance is given as s equals to 20t minus 2.5t squared. We are asked to find the distance covered between t equals to 3 seconds and t equals to 3 plus h second. This is from application of differentiation. This is from application of differentiation. We have the time interval 3 and 3 plus h. It's just a question of substitute. Find the distance covered. So uh, when t is when t is 3, what will be the answer? We substitute. Very important. Okay. So we have to find the distance between this. When t is 3, what are we going to have? We substitute. Then when t is 3 plus h, what are we going to have? That's what we have to do. Then we now minus the 2. Very important. When t is 3, what are we going to have? Very important. Uh, let's see what we can do between distance cover. Find the distance cover between when it is 3 seconds and when it is 3.3. So we have to find when t is 3 and when t is 3 plus h. When t is 3, what will be the distance? 2 into 20 into 3 minus 2.5 into 3 squared. Very important. Let's multiply. 20 times 3, of course, this will be 60 minus 3 square is 9. 9 times 2.5, that's 22.5. Then we'll minus 60 minus 22.5, that will be 37.5 meters. This when t is 3. Very important. When t is 3 plus h, what are we going to have? Very important. When t is 3 plus h, what will be our distance? Distance s now will be, we substitute 3 plus h minus 2.5 into 3 plus h all square. S now will be, let's multiply this 60 plus 20h. Let's expand this minus 2.5. It will be, that will be 3 plus h, then 3 plus h. This square means 3 plus h, 3 plus h. S now will be 60 plus 20h. Let's expand minus 2.5. 3 times 3 is 9 plus 3h. 3 times h, that's 3h plus h squared. Very important. Let's see. Let's move here to see what we can get. When t, let me write it before. T is distance. When t is 3, is 37.5 meter. That's when t is 3. Let's simplify this. We'll have 60 plus 20h minus 2.5. Bracket up, let's add this. This will be 9 plus 6h plus h squared. The distance now will be 60 plus 20h. Let's distribute this. 2.5 times 9, that's minus 22.5 minus 2.5 times 6, that's minus 15h, then minus 2.5h squared. Very important. The distance s now, that's the second distance now, this is the first distance, will be 60. We minus this, that will be plus 20h minus 15h, that will be 5h. Then minus 22.5 minus 2.5h squared. So this will be the second distance. The next thing for us to do is to see what we can do. We have to minus this. We are asked to find the distance covered between when t is this and when we have to minus these two. That's S2 minus S1 will be the distance covered between. We have to minus. Okay? So let's minus this. It will be, the final answer now will be 60 plus 5h. Then we can subtract this. We can say Okay, let me take it here first. Let me take it here so that we can do the subtraction very well. I hope we are together. Okay, S2 now, let's bring it. This is 60 plus 5h minus 22.5 minus 2.5h minus the second distance, which is 37.5. 60 now plus 5h, this will be minus, that's minus 20, minus 37.5 minus 22.5. That will be minus 37.5 minus 22.5. That will be minus, we have minus 60. Very well. What we are doing is minus 22.5 minus 37.5 will be minus 60. That will be minus 60 minus 2.5 h squared. As I said, we are looking at the second distance minus the first distance. That is S2 minus S1. Okay, 60 minus 60 will go. We'll be left with 5h minus 2.5h squared. This will be S2 now minus S1. We are asked to find the distance covered between when time is 3 seconds and when time is 3 plus h seconds. What will be the distance covered? The distance covered will be 5h minus 2.5h squared. Very important. We can, if we like, we can simplify this further, or we can leave it like this. So it will be all in meter, because distance is measured in meter. So all in meter. So this will be the solution, and the correct option is option B. The correct option is option B. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ's Maths and Further Maths Adventures for more interesting and amazing video. God's willing, in my next video, we'll continue from 24, 25, 26 down the line in that manner. Thank you for watching. See you in my next video.